Can you solve this geometry challenge? Here's the question. Given this semicircle, let's draw a chord that is parallel to the diameter of this circle. Now from here, let's draw some segments that are perpendicular to one another. And now from this point to this intersection, this is 4 units. And from this intersection to the other end, this is 3 units. Now, let's color this triangle as red. And the question is, what is the area of this triangle? Now, pause this video right now and see if you can answer this question, because I will show you the answer and the solution in 3, 2, 1. Alright, the answer to this question simply equal to 5 times square root of 6 divided by 2 square units. Now, of course, how do we get this answer? And here's the solution. Now, to answer this kind of question, we will focus on this right triangle. And to get the area of this right triangle, we need to have the length of the base and the length of the height. So, from this tip of this right triangle, let's drop a perpendicular segment and the other one which is perpendicular to the diameter of the circle. Now, let's call this as height. And this is also the height of this red triangle for sure. Now, let's call this segment, this small segment, be equal to A, since by symmetry, these two segments are the same. Now, we know for sure from this intersection to this point, this 3, and from this intersection to this point is 4. In short, if this segment is A, then this segment right over here simply equal to 4 minus A, and the other one is 3 minus A. So the total is just 4 and 3. Now, from here, since we have here a rectangle, since this part is 4 minus A and 3 minus A, so the sum of this, or the length of this rectangle, simply equal to 7 minus 2A. So this will serve as the base of our triangle, and H is the height. So if we get the value of A and H, we can now have the area of this red triangle. Now, the question is, how do we get the values of A and H? Now, take note, we have here similar triangles. So if we have this alpha, this angle right over here must be beta. So alpha plus beta is 90 degrees. So we have alpha 90 degrees, so this must be beta. And this angle right over here must be alpha. So these two right triangles are similar. So we can use the similarity of this figure. So we can say that H over 4A equals to the side opposite of alpha, 3A minus A, over the side opposite of angle beta, which is H. Now, solve H in terms of A, we have H squared equals 4 minus A times 3 minus A. Simplify this or multiply, we get A squared minus 7A plus 12. And this is equivalent to H squared. So we have now one equation in terms of A and H. So we need to have another equation in terms of A and H. So what we're going to do to have that equation. So first, let's locate the center of this semicircle. And now, let's draw some radius like this. And let's focus on this triangle. Now, what we know about this? We know for sure that from this point up to this point simply equal to 7 over 2 because the diameter is 7, so the radius is 7 over 2. Now, since this is 7 over 2 and this is A, the remaining segment must be 7 over 2 minus A. And also take note, from this point of this rectangle to the center, this is also our radius. So this must be 7 over 2. So now, let's focus on this right triangle right over here. Having side length of H, 7 over 2 minus A and 7 over 2. So using Pythagorean theorem, we have H squared equals 7 over 2 squared minus 7 over 2 minus A quantity squared. And simplify this, we get H squared equals 49 over 4 minus 49 over 4 minus 7A plus A squared. Now, subtract the two expressions and we get that H squared equals 7A minus A squared. Now, we have another equation in terms of H and A. So, using these two results, we can now solve for the value of any variable. So, first, since they are both equal to h squared, so we can say that these two equations are the same. And now, solving this equation in terms of a, combine like terms, and we get 2a squared minus 14a plus 12 equals 0. Divide both sides by 2, we get a squared minus 7a plus 6. Get the factor of this quadratic equation, we have a minus 1 and a minus 6. And since it is equal to 0, it follows that at least one of them must be equal to 0. So we can set a minus 1 equal to 0, we get a equals 1, and a minus 6 equals 0, we get a equals 6. But a cannot be equal to 6, because if a is 6, 7 minus 2a is a negative number, and we don't want to have a negative side. Therefore, x equals 6 is not possible. In short, the value of a simply equal to 1. Now, we know for sure that a is 1. So how about h? So using the second equation, we have h squared equals 7a minus a squared. Since a is 1, we have h squared equals 7 minus 1. And 7 minus 1 is 6. Therefore, h simply equal to square root of 6. Now, we know a and h. A is 1, h is square root of 6. In short, we can now find the area of this red triangle. Now, this h is square root of 6 for sure. And we know a is 1, so 7 minus 2 times 1 simply equal to 5. The area of a triangle can be computed using this formula, 1/2 times base times height. We know the base, this is 5. We know the height, this is square root of 6. In short, the area of this red triangle simply equal to 5 times square root of 6 divided by 2 square units. And that is the answer to this question. Therefore, given this figure, then the area of this red triangle simply equal to 5 times square root of 6 divided by 2 square units. And as always, we are done.